Okay, so today I want to continue what I started to do last week. And in fact, you will see some example I'm giving you. How do we represent the concept to use object-oriented paradigm to actually be able to model a complex object, like what you took care in homework assignment number 3. In fact, this might be useful. I know some of you already turned in your homework assignment number 3, and I haven't graded, so the TA is not here. Wait a minute, TA here? No, today TA is on strike, right? Is that right? Today is on strike? Okay, yeah, I almost, I was tempted. There is a small sign they want me to pick up. I almost want to pick up so we don't have class today, but now I decide not to do that. I decide you guys are more important, so I decide to come over here. All right, so if you actually realize that some of the work you turn in, homework 3 is actually could be improved, please feel free to resubmit by this Friday. Okay, so let me actually tell you what we have. Okay, I have to bring up my window. Sorry. It must be this window. Yeah. Okay, this is the piece of code that's actually contained. I have been using this code, adding more stuff each week when we actually go into this piece of code. I mean, I'm a big fan of actually learning it by really trying to do programming, adding this concept one step by step. So if we look at the GPS.cpp, and the concept we learn, which is initially for homework 2, I asked you to do this program called dump to JSON. Essentially, dump to JSON is convert your C++ object to a JSON representation. And last week I showed you is that not only you can dump it, but you can actually save it in a file. And which is important because if you save a file, that means if your computation ended or your program crashed, especially in the large scale system, crashing is unavoidable. You're going to have that. So we need to have a concept called persistent object. So meaning that when you write a program, you know your object is going to stay for a long time. It's not going to be like 1 minute after you had Control C and the object is gone. And next time you have to restart over again. Think about you're going to play Wordle. Think about the program. You don't want to start guessing the same thing every time you play the game. You want to actually save the state about your Wordle until next time when you finish 1 cup of coffee, you have some more idea, you actually will come back to look for that. Yeah.
Just double check. So for the assignment, we will have .json files, and every object will have its own .json file saved.
Yes.
So we wouldn't save all of them in one object. So
yeah,
they're not .text files.
Yes, you should name it .json file. Yeah.
So in that sense, every object will have its own .json.
Right. Right. Every file, object has a .json file. Yes. Yeah. Did I show everybody the demo about saving the .json file? If you look at this ls, this is actually from last time. If you look at the JSON object, you see that I saved every GPS object, every thing object with object identity, with a class name, with object identity, and .json. And then if you look at that file, let's go to JSON object. Let's just look at GPS. You see, GPS is basically just a key value pair, and this is the exactly equivalent information to the object we create for maybe IKEA in West Sacramento. And if you actually do a thing And that is essentially the output. By the way, this is the output of dump to JSON, which you should already have it for homework assignment number 2. And you just using some of the function routine, which I provide under, I think it's called ecs36b underscore JSON dot CPP. Over there, there's a set of routine that you can actually write it to the file. And I gave an example, by the way, this is an example I gave on November 7th version, which is, I think it's on HW5, client.cpp. This part, sorry. Did I have this file here? No, this is different. Here is the, I think here it is. JSON, project.
Professor, are you looking for my JSON the file?
Right.
I saw that in Homer 5 server, but I didn't really.
Oh, yeah. Okay, so that's in Homer 5 server. Thank you. I forgot.
I thought you called it. I'm not sure.
Right. No, that's the place I was talking about last week. Thank you. I actually completely forgot. Yeah, here. This part is the server part. You can see that what I did is I use this function. I create a file name for /JSON underscore objects, and then %s. The first %s is a class name thing. The second %s is object identity. And that's the object. And how do I actually save it? I use dump to JSON to get the Swedish Middle from the C++ format to the JSON value version of the Swedish Middle. And JV is essentially the JSON representation of the objects. And then basically, when I call this function my JSON2 file, it's just a name buff. Name buff is what? Is the name I just created. And then with the JSON value with the reference to that. And then this function, my JSON2 file, will actually write it over there. Yes.
How do you call the my JSON to file function? Like, I understand that it's been another CPP file, but there's no like includes, or is it just through your make file that you're able to do that?
Okay.
You can turn it into a dot.
Right. So let me actually tell you that I might neglect some detail. If you go to ecs36b, let me actually just do a graph. The best way to find out how do I be able to include that, that's why I give you the source code. You do a grab, my JSON2 file, star dot, I would say ch star. Okay, so this will search for all the things that's actually have my JSON2 file under CPP file or H file. So you can see that I actually grab it. Now you see that this POR from CPP from HW5 server. This was the place I call it, but the implementation is actually under ecs36b JSON.cpp. I actually define the function here. And then the trick is, how do I actually include it? I actually include the what we call function prototype in ecs36b common.h. So that's the include file. So both HW5 server.cpp and other function when you want to use this, you always have to include ecs36b common.h. When you include it, the compiler will know, oh, this is the function prototype. And then when you link it, let me look at the make file. If you look at the link, the make file, inside the make file, in the object somewhere, wait a minute, in the make file, in the server, must be executable file here. Yeah, here. You see that when I actually link this two together to make HW5 server, I have HW5 server.o ecs36b JSON.o. So ecsb JSON.o is where the function my JSON file was included. Okay, so let me just repeat what I said. The function prototype, because you want to link to a function, this is what we call separate compilation. Means that you don't include the source code, but you actually only include the function prototype. So the linker is going to link them together. The function prototype is in a program called ecs36b underscore common.h, which
This file was not uploaded to assign the common file that was given.
Okay.
The prototype,
Okay. Okay, so but was that file in the 1107?
I think it was.
Could be,
Yeah, if it's in 1107, yeah, just use the new one. Yeah, use that one. Yeah.
we just link the common files.
Right, right. EC36B. Yeah. So yes, yeah, I on one hand I want to say, oh, I'm sorry, I forgot to do that. On one hand, I feel I'm so proud of myself. I intentionally forgot about that. So make sure you learn from this mistake. No, I'm sorry, I forgot to include the newest version. Yeah, I have a different version. That's why I need to have a version control about everything, every piece of code. Yeah. Okay. Does that answer your question about okay? So any other question about using this my JSON to? So basically, there is a piece of code called ECF36B JSON.cpp include a bunch of utility, and it was separated compile. So you look at the make file, and you will see that. Let me just show you how it's get compiled. You can see that the way I structure my make file. I have object code, which is include all the base object, like a GPS, network, JV time, person. This is our all baseline. I included here, but I also have things like a utility. This line is actually compiled. This two line, ECF36b underscore JSON.o. This is actually trying to compile that utility function, and then this one was actually linked with this function over here. Okay. All right. Is that okay? All right. So now I can.
And for the string friend function, do we update it to the new SN friend function?
It's up to you. It's okay. The thing is, I'm kind of lazy. I didn't use SN scanf. Wait a minute. I didn't use scanf. I didn't use SN scanf. I use scanf or sprintf or SN printf. So the difference is that sprintf it doesn't check how much memory you have. SN printf, they actually need to provide how many characters. So it's actually check for the buffer, whether the buffer overflow. So sprintf and scanf is older version, which I developed this code at that time. It didn't even generate those warnings, but I always know that it has that vulnerability. So for this homework assignment, if you want to change to SN printf, that's perfect. But if you don't bother to do that, that's fine. Yeah, but just be careful. Those warning message, they mean something. Yeah. Okay, any other question? All right. So, okay. Let's see, did I have a copy here? Okay, yeah. Okay, so we talk about this dump to JSON. So dump to JSON is basically just converted C++ to the JSON world. I do want to say that some of you might feel odd that why do I need to learn this? Because while we're learning C++ object, we're happy with C++, or I'm writing a Python program, I'm happy to do that. Why do I need to bother about this function called dump to JSON, which essentially I'm converting? A homework 3 is essentially asking you to convert it back, this two-way street. Some of you actually got it, some of you are kind of a bit confused about why we're doing this in a C++ programming. Okay, so let me tell you there's a few very important reasons why we need to do this. The number one reason for us to do this is actually there are so many different kinds of object-oriented language. And the thing is, as a computer programmer, that you just need to keep updating yourself because there's a new language that come up. But among all this language, there are actually two different types. One type is what we call strong type, or what we call structure. Strong type and structure, meaning that you actually have to mandate what's the data type of these things. And the compiler is going to check the data type very rigorously. And also, the other one is called structure, meaning that you have to have every single element when you define the containment hierarchy. So that is one extreme. I will call it structure, strong type. That's C++ or Java. But on the other side, in industry, we realize that we really don't want to be delayed by dealing with strong type. Because we want to have a flexibility. We don't want the compiler to stop us. We want to actually wait until the runtime to actually determine the type. So this is the extreme. The other extreme is JSON. So JSON not only is a weak type. In turn, I shouldn't say it's a weak type. It's actually doing type checking at runtime instead of at compiler time. Well, in some sense, in some programming language, people say, yeah, that's a definition of weak type. Anyway, the other very important reason for you to understand the difference is that JSON is what we call non-structured. So when you define a C++, you have to say what's the component. You have to act in your virtual code, your pseudocode, you have to write everything. But in JSON, if you actually have 50 elements you want to put in, but you don't remember which 50, you can actually start writing, starting with 3, the part that's relevant to what you have. And then you can actually start to get your program running. So some of you will already get your exposed to data analytics. In data analytics, you have this two concepts. One is called SQL or MySQL. You probably heard about that. That's basically you define a table, a lot of columns. But there's another part is called non-SQL. So non-SQL meaning that I don't have that structure. You can actually define whatever you want. And the representative of non-SQL, guess what it is? It's JSON. All right. So essentially, that's the one thing I want you to learn the both extreme. So even though that the curriculum does not clearly specify that you need to learn the difference, but the thing is, it's important to learn object-oriented programming because we do. When you want to deal with the data, you have the structured one, you have the non-structured one. I mean, it's very artificial when you want to use a language like C++ to deal with non-structured. The ideal way of dealing with this is that if you know the data is actually structured, use C++ because it's efficient. But when the data itself is like a JSON type of data, is non-structured, and the best way is actually process using JSON, and at the end, you try to actually convert it back to C++ to integrate with the rest of the data. So I just want to motivate you that why this two-way is important. You learn dump to JSON. So that's what we look at, how we can convert it, the C++ to the JSON format. But homework assignment number 3, I introduced a new concept which is converted back. It's called JSON to object. So I want to show you this example. What it does, the coding is essentially do a bunch of check whether the JSON. Remember I said, what is JSON? JSON is actually, I won't check the data type or check the structure until runtime. So it's very naturally in the JSON programming, you're going to have a lot of code looks like this. I want to check whether this JSON is null, whether this JSON is an object. That is the check. And then I check whether you have a column or attribute called latitude. You want to see if you do have the key value pair, the key is latitude, is null. And then you actually check whether the value part of the latitude or longitude is actually a double. So you see, I'm actually checking the value, the data type, whether it's a double or is an object or is a string at runtime to do this. We'll see some examples. So this is actually the way I can actually convert a JSON object. At the end, after I'm done with all the checks, so the first like a 6 or 8 line, they were basically just doing the things compiler is doing. But I'm actually doing a weak type system like JSON. So I have to do this kind of check. So after you finish the checking, you know now it's safe to write that value into your C++ object. So guess what I did? This at latitude, I'm only give you one example, is actually I say that the JSON value object extract the portion of the latitude and then convert it as double. Because I already checked it's double. So I actually do as double, means I convert that value into a double value and then save it to C++. You can see that this is a really good example about how you can interoperable between a weak type system and a strong type system. And by the way, the other thing is always good. You probably heard the word called bilingual. I mean, in object-oriented programming, it's really important for you to have this bilingual capability between the weak type and strong type. Essentially, after you get out of this classroom, you will be able to handle any object-oriented situation. Okay, so that's the example I gave you last time. We handle a very simple dump to object, but using only the GPS. So I want to give you a little bit more extended example this time. So this homework assignment give you another one is person.cpp. So first I want to go to person.h, sorry. So inside person.h, now this particular version of the code, I actually have a implementation for JSON to object. So I'm actually done a JSON value, which is represent a person object and dump into using JSON to object. So let's actually take a look how I implement. It's actually same style, but this time you will see some recursion because I'm actually calling dump to JSON at a person level, and the dump to JSON at a person level is going to call GPS dump to JSON as well. It's not really recursive, but because it's recursive on a different type. Okay, so let's actually take a look at this. Dump to JSON. Okay. No, not dump to JSON. JSON to object. Sorry, this one. Okay, starting from line 91 in the code that I actually shared today. So again, you see that I'm actually doing strong type, weak type kind of check, but at the runtime. At the runtime, the compiler don't know because JSON doesn't have any type, by the way, so I have to use this to check. So the first thing I actually check is null is object exactly the same as the GPS. And then what I did, you see that because what person.h has a bunch of variable student or social security number and the name, right? Those two must have it because, by the way, if I want to convert an object, that person doesn't have an SSN, I'm going to reject. I'm not going to create a C++ object doesn't even have those two attributes. So that's important. I want to check those attributes exist. but the type instead of is double, I'm actually check is string. Whether this is actually the data type is right. So you see again, I'm actually checking the type at runtime instead of compiler time. Okay, if you have all this, great. Then what I did, you can see that I'm actually writing this to the SSN, which is the social security number, is equal to the same thing, Java, it's not Java, JSON object, SSN, extract the object as string. I'm actually turn it to the string type and then put this into the SSN. You can see a lot, another way for me to actually construct this bridging between the JSON, which is the weak type, into the strong type, using the function that's provided at runtime. Okay, so that part is very similar. Now we're going to see a little bit more complicated is how do I handle GPS? So the next two, you can see that I'm actually doing home and location. By the way, if you look at person.h, both home and location, they're GPS. They're GPS DD. They're object. So I basically check is null, they shouldn't be null. You should have home address. You should have a current location. By the way, you might be able to change to say, okay, this is optional. Then you can actually avoid some of the check because probably some of the attribute you don't care. And then you can see this is a little bit different because what is home? Home is a GPS DD. And GPS DD in the JSON terminology is actually an object. Okay, it's an object. What is an object? Anything beyond basic type is an object. Oh, by the way, there is a few things. This place could be is object or is double, is null, or and the other one it could be is array. There's another type which is not simple type, is array. Is array. That's another thing which I hope I can show you a more complicated example, but not worry about array. If you learn about what you learned today, you should be able to extend this concept to is array. Okay, that's another one which we haven't seen. So this is object because home is a GPS DD, is a C++ object. It's not a basic type because it has multiple attributes. It has the longitude and latitude, so it's an object. In JSON, an object is anything that's actually contained in a pair of curly brackets. Yes, please, in fact.
I don't know if I missed this, but when you run JSON to object, is the output the same in run to JSON or does it look different?
So when you run JSON to object, you basically write the value, you convert the JSON string into a value. So when you actually then you call dump to JSON from the object you just made, then it should be equivalent to the JSON string you actually entered. It should be, I say it's equivalent. Equivalent means that, by the way, JSON doesn't have any order. So if I say this is my latitude, this is my longitude, if your input is latitude first, longitude second in the JSON string, if the output is a reverse order in JSON, they're equivalent. The orders are different, but they're equivalent. So just to let you know, JSON doesn't have a sequence concept. Okay, does that answer your question? Okay. Yes.
When you're putting the value in the JSON back into an object, you first like make an object that's like a default constructor where everything is just set
Right.
to ignored. Okay.
Right. I'm going to show you how that works. Okay. Yeah.
Is there a reason JSON to object is a boolean and not just a void function? Since all you're doing is assigning the
That's a good question. So I could actually just say void, but the only reason I said Boolean is because if you gave me a JSON that's actually EO form, or it doesn't have some information which I'm expecting, then I'm going to actually return false, meaning that you missed some element. So I might actually return another, like a return code, an error code, I mean, that's just because I want to have a simple way to say whether you have all the elements, whether you actually, for example, if you have a person who doesn't have a location, you can see here I return the false. Okay, that's the reason. Okay, any other question? Good, all good question, thank you. Okay, so if I have this, now you haven't seen this part. The whole thing I want to show you now recursive. After I pass this few line, that means I have the home, I have the location, and the home and location are both object. Object means they're JSON object. And then what I do, you can see that I'm actually calling, because what is this home? This home is an object to GPSDD. So inside the GPSDD, remember I showed you earlier, there is a function called JSON to object. So then what I did, you see that I just basically extract the home portion of the object into the parameter of this function, and then I call it. And then the same thing I do for location. So let me actually tell you what's happening. So you gave me a JSON representation of a person object. So inside the JSON to object in the person class, I extract this portion of the object from the home. And then that home is, by the way, if you look at it, this is the latitude and longitude. And I actually extract that from this home using argjv and then using the home. I extract that object. When I extract is actually a JSON value object. There's a JSON value, then I basically call the home's JSON to object. So from person's JSON to object, I actually call the GPS JSON to object. Let me actually just connect you with the other piece of code so you can, hopefully you can connect better. So this one is GPS.cpp. It has a code. This piece of code called JSON to object. This is essentially, I'm actually converting a JSON object to a C++ GPS object. So what I'm doing here is that this code, once I get this part out, I'm actually calling that piece of code on the top. So essentially now I'm actually converting that part into a C++. So the thing is that right now, this is called containment hierarchy, by the way. What's containment? A person contains a GPS object. In fact, it contains two. One is represent location, one is represent home. But the way I structure the code, I have this JSON to object. I basically use the same function. I just call it, I'm done. Okay, and that's how I actually do that. Any question? I mean, this is probably the most difficult part about this part of the lecture, because for you to construct the JSON is usually easier because you know the attribute, you learn about how to represent the JSON, you can kind of produce a JSON string, you can validate. That's great. That's why we actually taught you that part first. But how to actually convert it back is from a weak type converted to a strong type. That's usually pretty hard. Yeah.
Okay. One thing. So when we do the check, we want to make sure the object is not null for the JSON and it's an object, and then we check for the values. Why do we have to do that? I mean, when we have the functions for every class that dumps JSON, we did the validation there when I created it. So right now I'm like, okay, it's now null, and I do have a valid object.
Oh, okay.
There
is a big difference. The JSON value I actually provided here for you to do the JSON to object, it might not be produced by dump to JSON. It might be produced by someone else. It might actually be produced by me. I actually handwrite it. I just type in an object, right? So by the way, JSON is so natural. It could be produced in any other way. The thing is that, let me tell you a very practical situation I personally had to deal with. So I was actually processing Facebook posts. So Facebook posts from Facebook, they just keep changing the format because Facebook want to make sure that people like me, I cannot use the same program to analyze. But their code represent 2 million lines. They're using JSON, but they sometimes twist the format here and there. So when I process that, I have to use this code to actually check whether you have this, you have that, and then decide what kind of object I can construct. So in that case, I don't have any guarantee. And sometimes I remember there was 1 year, I realized Facebook actually removed the Facebook user ID for all the people who click likes. And that's obvious, they should have done that a long time ago, but they actually make that change, which make me, when I construct this, I have to modify my code to do that. Yeah. So think about, this is the general approach. I want you to know dump to JSON and JSON to object. But think about that, they're very powerful when they separate, when they deal with this non-structured world of information. That's actually the power of using JSON. It's really, really, really flexible. Yeah. Okay. Yes, please.
From what I see, it makes sense to use JSON to object as a constructor to sequence something. Doesn't it?
Yes, you can do that.
But
Yeah, that makes sense.
But
Yes.
the constructor could not have a value, and for instance, if I pass a JSON which doesn't have any of those values, then how can I say that? How can I say that this object is not created? That they could not create this.
Okay, if I understand you correctly, you're actually talking about I have a constructor, and the constructor only takes one argument. That argument is a JSON, right? And then I basically use the JSON to object and convert it to that, right? And the issue you actually raise is exactly unavoidable. Means that I still have some way to check whether the value I'm expecting for that C++ object, it is actually in the JSON value I have. So this actually raised two issues. That one issue, we need to do that kind of check for everything. But the other issue is that we might be able to develop some kind of object constructor, which some of the argument is going to be optional. So if you don't have this, it's okay. So we might actually, so the code in the constructor, they need to check which attribute is okay, which attribute is not okay. Yeah. All right. So let me actually tell you, since we're hit on this topic. Anybody remember what will be homework assignment number 6? Wordle. Distribute the word. I changed that, by the way. I changed that. I feel I want you to do Wordle. Okay. In Wordle, so if you guys actually provide some guess for the word. So think about what Wordle is doing. Is that I actually provide a 5-letter words, and the server basically give me what is the result, right? Whether I guess right or guess the right position. So that's the result. Okay, so guess what? The number 6 is allow you to share that information with everybody in JSON. You actually represent that in JSON, and then you will utilize that information to actually decide whether you can actually break the puzzle with the help from others. So that's actually distributed. That's why I call it distributed Wordle. So you can think about there is a very important step related to the question you asked, Dennis, is that one of the students decide to represent the result of this 5-letter, they use the result. But the other student might actually decide to say, I want to use a different words called matching. So one of the students, the key value pair is result. One of the students is actually doing matching. So essentially, in the programming world, this is just so practical, because when the information across different programming language, that's the attribute, the name of the attribute is going to change. For example, student ID number is equivalent to social security number or not. That is actually very, what I call sometimes raise some kind of ambiguity. So the thing is that how do you actually be able to convey the program in such that you will be able to capture this kind of difference? And we will address that when we talk about in homework assignment number 6. That's another very practical way, practical issue you need to deal with in today's internet world. For example, how do I actually be able to analyze the information that I collected from Twitter and Facebook? And Twitter, we call what do you call that? I follow you. What's the words of Twitter? They not tweet, retweet. For example, they have the word called retweet, and then Facebook will share as example. They're similar concept. How do you actually be able to represent an object uniformly, represent the information, so we actually be able to analyze what's the marketing trend today about certain topic? Okay. All right. So now let's actually come here. I hope you got this part. I have 2 minutes, but I would really want to go quick. Okay, this part is just, I have the code. This part dealing with the JV time. Okay, since when is JV time? And this one is GPS. But I want to show you the code. I actually saved it in HW5 server. No server, client. There is. There should be, right? There is it is in JV time CDB. It's the JSON to object. I have an implementation there as well. Okay, let's actually look at this piece of code. This is what I did about a week ago when I look at this JSON object. And now this is the code I'm going to talk about this. I have a person called John. And I set up John's whatever IKEA location over here. Okay, look at how I use dump to JSON and JSON to object in this case. This part is a demo for today as I comment here. I actually first, I use the C++ object John, and I call dump to JSON, meaning that I actually converted to ABC, and ABC is a JSON representation of that C++ object. Now that's in ABC. And then I actually create a a empty constructor, a default constructor. I call it John clone. I create a John clone. And so now I have another person object called John clone, but the John clone is actually a null object. It means it doesn't have anything make sense. Okay, then I basically call John clone dot JSON to object of that ABC. So now I'm actually really doing the copying. ABC, what's ABC? ABC is a JSON object. So I call JSON to object over there in that line, but what's the input? Is ABC. I actually get it out from the very conveniently from the object, C+ object John. Okay, and after that, what I did, I want to just make sure they're different. So this step is actually extra, just for demonstration. I actually set John clone's name to be John clone. Okay, I just set the name to be John clone, and then what I did is I do a John clone dot dump to JSON, and then I print it. Okay, that's the piece of code. You can see I'm just playing with this two world, C+ world to JSON world, and then now I'm shuffling back to the C++ world. So just show you, you can actually play this yourself. Some warning, don't have to worry about that. Run the server. Actually, in this program, you don't even need to run the server because everything, the things I want to show you is in the client side. But, okay, so here's the result. But take a look at this. This is the thing which was the John. That's the other one which has ownership was John. But that is actually the dumping the thing. But the thing is actually printed out is over here. This is when I actually dump to JSON on the person John Clone. And because the name has been changed, to John Clone. And then if you compare every single information related to the other one, John's over here, they should be identical, everything, because I actually just literally just copy over. Okay. All right, I'm going to stop here. This hopefully give you a two-way street for you to understand this two direction. It's actually pretty challenging because let's think about, I'm actually asked you to do bilingual in programming language. But this basically cover everything you need to learn about the two type of information processing. Okay. All right. So I will stay here. I'm not sure TA will be here because he is on strike, but I will be here until 5. Sure. Give me, should I turn off my recording first?
It doesn't really matter. It's